Good morning, everybody. This is a live streamed severe weather briefing. Mainly, we're going to be talking about the severe weather threat that could materialize across North Texas late tomorrow night. There is a slight risk that the Storm Prediction Center has issued. But first, I want to go over this Supercell diagram that I created for the class coming up on Monday night. This is similar to the educational content also that I'm going to be delivering on a weekly basis through the Facebook supporter platform. The Facebook supporters make live briefings like this possible and the live storm chases possible as well. Let me first show you the slight risk that has been issued by the Storm Prediction Center across North Texas, the Red River region, into extreme southern and southeastern Oklahoma, and it includes the Dallas-Fort Worth Metroplex area. But again, this is for late tomorrow night. Kind of some unfavorable timing with the trough ejection. That trough right now is located over California, and it's expected to peak over the southern Rockies and then shear out as it ejects across the southern plains and Dixie Alley. The Dixie Alley severe weather threat on Monday is not looking quite as substantial, but I do think that there is a threat of severe weather late night tomorrow night here across North Texas, and we'll break down that risk in the forecast models. But first, here is this Supercell diagram, and we're going to be discussing this as well in the class Monday evening coming up with varsity tutors. But first things that stand out initially with this Supercell diagram are, of course, the debris ball here, the perfect supercellular structure, very laminar appearance as well. This high-resolution radar image is from the Radar Omega app, and this was also a supercell that produced the Tuscaloosa EF4 tornado during the super outbreak on April 27th, 2011. You can even see this left split supercell lifting off to the north away from it. You can kind of see how it has more of an anticyclonic concavity there with that mesocyclone lifting off to the north. I call the rotating updraft of a left split also a mesocyclone, even though it does have anticyclonic spin lifting off to the north. This one is the right mover, obviously down here, a dominant supercell produced an EF4 tornado that probably could have been rated an EF5 as well. Here you can see the jet stream wind, prevailing jet stream wind out of the southwest to the northeast, and that creates these two counter-rotating wake eddies downstream. You could basically consider a supercell storm almost like a rock in a river or a stream, with the jet stream wind being the flow of that river. And if you had a rock embedded within that stream, the water has to flow around the rock, which is basically an obstacle inside that river or the creek. And when the flow goes around it, it creates these two counter-rotating gyres downstream. And a supercell does the same thing when it's embedded within those southwest and northeast jet stream winds. That's why you get this flying eagle configuration to the shape of the reflectivity pattern, with the hook echo on the southwest side being the eagle head. These are the wings of the eagle downstream, or those counter-rotating wake eddies downstream. So I identify these basically using weaknesses in the reflectivity. You can kind of see where those two counter-rotating wake eddies reside. A couple of other things that you can see are the two downdrafts. So in general, a supercell storm consists of a rotating updraft and a couple of different downdrafts around it. One is back behind the mesocyclone. In general, this area right here is a big rotating updraft above the smaller scale tornado back below it. This is a very tilted updraft that does have some rotation, which helps to enhance the updraft as well, acting as almost like a giant tilted vacuum cleaner above it. And then any eddy or even a dust devil, gustnado, anything that forms along this surging RFD gust front, if it propagates underneath this vacuum cleaner, it can be stretched, it can couple with that updraft, and just like a figure skater that's spinning around in a circle, when they pull their arms in, they spin faster, and that stretching motion helps to intensify the low-level vortex, and in this case, an eddy along that surging gust front there likely helped to develop this EF4 tornado. You can see the debris ball there as well underneath that, but that giant mesocyclone and the enhanced updraft above it will support hailstones that grow, accumulating layer upon layer of ice, and the largest hail falls just on the north side of that mesocyclone, aided a little bit by the mid and upper level winds transporting those hailstones, largest hailstones, to the north and northeast side of the mesocyclone before they fall to the ground. And that large hail core is indicated there by the blue egg. And this is what you have to punch through to gain visual of the storm. Let's say you're heading from north to south. You punch through that hail. Hopefully you don't lose your windshield. And then you emerge into the bear's cage on the south side of that hail core. And you can often gain visual of the tornado just off to your south. Usually it has a really good contrast as well, illuminated by the sun, the sunny skies off to the south of it when you punch through that hail core. I think that the safest approach for a tornado is called a hook slice maneuver, and that's when you go from west to east to the hook. A lot of times you get rain curtains, sometimes even some hail as well in the northerlies there in the hook. Usually it's just a couple of curtains of rain, at least of the classic and definitely the LP supercells. But you punch through that hook echo, do a hook slice maneuver, and one advantage of approaching from the up shear side, the jet stream's going like this. So when you approach from the west to the east is you can always stop the vehicle as an escape route and then allow the tornado to move off to your northeast, likely doing the left-hand turn that they often do as these tornadoes mature, like the Greensburg EF5 tornado that did that very sharp left-hand turn, the infamous El Reno tornado that also did that very sharp left-hand turn. We've been anticipating that left-hand turn for years as storm chasers approaching from the up shear side, doing a hook slice maneuver. The El Reno, Oklahoma tornado of 2013, a 2.5 mile wide tornado. We also did a hook slice maneuver on that one, and we saw just off to our southeast that massive 2+ mile wide wedge with sub-vortices inside it, up to a 1/4 mile in width, spinning around like a merry-go-round. And we actually ran into some power lines, attached the electric wire around the light bar on the hood of Dominator 2. And when we were trying to free ourselves from that power line while inside the northern side of that wedge tornado, almost like a slingshot, it tightened up the electric lines, shot the hood out like a frisbee. We saw it go into the tornado. And I know it's kind of cliche, but the hood actually never hit the ground. But we were able to stop and allow that massive tornado to evolve off to our east and then do that left-hand turn. And stopping the vehicle, even the Dominators, can always be utilized as an escape route when you're approaching from the west to the east direction and punching through that hook. But the two downdrafts of this supercell storm are the rear flank downdraft, indicated by this gray area. That's on the backside of the mesocyclone. The mesocyclone here is such a strong updraft that you get balancing sinking motion on the backside of it, called the rear flank downdraft. That rear flank downdraft hits the ground and then accelerates in a horizontal direction, whipping around the south side of the mesocyclone, enhanced by the drying out of that air, the sinking motion as well, the momentum hitting the ground and then spreading out because it has nowhere to go once it hits the ground, wraps around the south side of that mesocyclone. So if you're approaching a tornado from the south direction, going from south to north, a lot of times you'll get dust within these damaging westerlies to the south side of the tornado. You will often have to punch through that dust to gain visual of the tornado vortex. We had to do that in the LP Supercell on the Ray, Colorado day on May 7, 2016, just to gain visual of the compact tornado vortex out ahead of it. But this surging RFD gust front right there and that boundary that's identified by this black line right there, that surges out almost like a dry line, like a bulging dry line on the south side of the mesocyclone that's right here. And out ahead of that bulging dry line, which will often have a shelf cloud along it as well. Sometimes you can get beautiful shelf clouds along this surging gust front, almost like a surging squall line with westerlies back behind it. But out ahead of it, you get the inflow surging from the southeast, ideally in this fashion. And it heads toward the inflow notch, which is the notch between this rear flank downdraft here and the forward flank gust front off to the north. This is the other downdraft, the main primary downdraft called the forward flank downdraft, and that's as the jet stream winds west-southwest to northeast transport the rain and the hail from this mesocyclone downstream, and then as it falls downstream in this downdraft, that's the forward flank downdraft. And this little stationary front on the south side of that cooling, evaporationally cooled air there in the downdraft, in between that and the RFD is called the inflow notch. And this is also the area where we're trying to shoot rockets into it. We shoot our rockets into this inflow notch here. Ideally, they get transported into the tornado. You also have northerlies here on the north and the northwest side of the tornado. Sometimes it's referred to as the ghost train on the backside, kind of an area of condensation sweeping in to the north side of the tornado. An area of vorticity also comes in along this gradient of the hook there in those northerlies, and that vorticity enhances the tornado cyclone even more. That's getting stretched by this vacuum cleaner of a mesocyclone up above it. But this inflow notch, that's where we're trying to aim our rocket launches. And then the parachute deploys, carrying the trackable sensor into the tornado. It gets entrained into the tornado by these northerlies on the north side of it. And you can see the tornado in this case with a reflectivity ball here called a debris ball here on the super outbreak. And just about every single supercell, almost every updraft or thunderstorm that developed during the super outbreak would quickly attain this perfect supercellular structure that's depicted here by this radar omega image. But again, today we're going to be talking about severe weather that could impact portions of North Texas into southern Oklahoma. Tomorrow night, it's a nocturnal severe weather event. I've kind of been down on this event for a long time because of the rate at which that trough is forecast to shear out over time. The Storm Prediction Center actually dropped their outlook for this yesterday in the day 3 outlook, but now that we have a day 2, a slight risk has been reintroduced here. And again, this is for tomorrow night, the Red River region, and I'm wondering if we're going to see any supercells like that. The perfect supercell image that I just showed you. I doubt it, but there is a chance that tomorrow night there could be just enough instability and just enough wind shear. Maybe there could be a couple embedded transient supercell structures. More than likely, though, this is just a low-end severe weather threat tomorrow night, late tomorrow night. And part of the reason why it's low end is because of the late arrival of this trough. There you can see the trough on the morning NAM. That's out here over California. Right here, it looks like it's an intensifying trough. A lot of the flow is loaded on the back side of this trough. That flow wraps around the base of the trough, and then you get speed shear, curvature as well, contributing to that vorticity at the base of the trough as that jet streak rounds the base of the trough there, causing it to deepen. And then the flow rounds the base of it and then is concentrated on the east side of the trough. And at that point, the trough is beginning a weakening trend. It shears out, kind of has a flat appearance on it. But this is this Saturday morning, the trough that has prompted that slight risk here in California, just off the coast of the California, just offshore California, coming onshore though during this weekend at Fort Max. And watch this flow as it wraps around the west side of it and then wraps around the base of the trough. That's when this trough reaches peak intensity. Right now, it's got a little bit of a positive tilt to the Fort Max here to the trough axis. But then as that flow rounds the base of the trough gains a more neutral tilt. And really, you want this to be happening as the trough is ejecting the southern Rockies during a period of favorable diabatic heating. During the winter, the timing has to be even more perfect. During peak heating to generate daytime severe weather. It's a little bit easier to get nighttime severe weather, but harder to get that severe weather to be surface-based. So this is by tomorrow morning, Sunday morning. Notice how all the flow here at the mid and upper levels is now rounding the base of the trough and already starting to spread downstream of this trough. You can see that it's starting to gain more of a neutral tilt. This is when you want the trough to be ejecting from the southern Rockies across the southern plains or even Dixie Alley. To maximize the severe weather threat there, to maximize the intensity of the southerly low-level jet out ahead of it that transports some moisture northward. And the sea surface temperatures down in the Gulf of Mexico are below normal after a very active hurricane season this fall. So I think that's why we're going to have a late start to this severe weather season, the core of the severe weather season, similar to 2011. That year, February and March, was incredibly inactive for severe weather. Everybody was saying that it was going to be a nothing burger for the entire year for severe weather. And then April rolled around, and you had April 9, the Mapleton, Iowa event up there in northwestern Iowa. Then you had the April 10th event in Wisconsin as we were chasing tornadoes with snow cover and frozen lakes in the ground. Then you had April 15 with over 100 tornadoes across portions of Dixie Alley, where we saw that morning tornado at 10:30 in the morning out near Clinton. Then April 19, the big outbreak just to the north of St. Louis and across portions of Illinois. Then, of course, we had the super outbreak from between April 25 and April 27 with over 360 tornadoes over 20 states during that 3-day period, including over 200 tornadoes during a single day alone on April 27. I'm not saying that's going to happen again this year, but that is the last La Nina that we had coming into spring. The sea surface temperatures in the Gulf of Mexico were also below normal that year, leading to a late start in severe weather season. But we had this consolidated jet stream with a series of open waves just surging west to east across the United States. And instead of getting those stagnant cutoff lows, split flow patterns, as you usually see with El Nino events, we have a tendency for this La Nina winter into spring to have a consolidated polar front jet stream and these open waves moving from west to east across the country. Pretty favorable pattern for low-level jets. For transporting moisture northward and for generating wind shear, favorable for tornadoes over a very large area. But in this case, I think that the moisture is going to be a little bit lacking. And as we mentioned, the timing of the evolution of this trough is not quite favorable enough to generate a robust severe weather threat downstream. Look at it by this time as it's starting to eject from the southern Rockies. This system is already pretty flat, getting sheared out over the subtropical cyclone anchored over the Gulf of Mexico in the southeast, and that causes this system to weaken on approach to the southern plains, and especially Dixie Alley. It almost loses its identity completely, ejecting over the trough. But you can still see some cyclonic curvature associated with its storm system upon arrival to the southern plains tomorrow night. This is at about 2 a.m. Central Standard Time when the upper level dynamics finally eject over the plains as a shearing out system. You can see this system coming in here to California, the kicker system coming in behind it. This is the one that everybody's talking about that might bring a chance for a coastal storm system downstream. But one thing you'll notice is that the atmosphere provides hints as to what's going to happen downstream, and I suspect that this system is also going to peak a little bit too early and then shear out over top this subtropical ridge and probably bring that snow a little bit further north than some of the hype forecasts are showing right now, with Washington, D.C. maybe even getting some snowfall. But here you can see the trough ejecting by Monday morning over the southern plains. And let's continue to advance in time to show you what this is going to do over Dixie Alley. The NAM is showing a system that's rapidly shearing out as it's surging off to the northeast toward the southern Great Lakes. And that's why I just don't think Monday is going to be a severe weather event in Dixie Alley. The NAM does have some marginal instability out there, especially along this front. But as that system shears out and lifts off to the northeast, that's likely going to bring the better dynamics well to the northeast of this instability axis that's over far eastern Texas, closing in on the Louisiana border by midday on Monday. Let's look at the dew points here. And with that system lifting rapidly off to the northeast, instead of being a relatively deep, maturing upper-level storm system, it's just not capable of generating a robust low-level jet that's backed enough and strong enough and large enough to really pull these deeper dew points northward from the central Gulf of Mexico. All the good dew points, mid to upper 60s and 70s, are basically from the central Gulf of Mexico and further off to the south, especially over the western Gulf of Mexico, where those sea surface temperatures are a little bit less moderated. They're warmer out there. Not as anomalously cold. That's where all the moisture is located. And to tap into this reservoir of deeper dew points, you really need an upper-level storm system that digs into northern Mexico there, then across the southern plains, matures as it exits the southern Rockies. Then you're going to pull that moisture northward across Dixie Alley. Still, though, even though the low-level jet is quite veered and rapidly ejecting off to the northeast with that shearing out storm system, there still is a chance that down here along the tail end of that shear, maybe southern Louisiana, maybe up towards southwestern Mississippi, that you could generate some transient supercell structures down there. But really a lot of capping, a veering out low-level jet, more westerly there, and I just don't think that the thermodynamics are going to come together enough to generate a robust severe weather threat across Dixie Alley on Monday. But let's look at Sunday night across North Texas. Notice how this low-level jet, it does develop late. This is at 3Z Sunday night across the southern plains. Let's zoom in on the regional level here on the Pivotal Weather website. And this is at 3Z, so this is 9 p.m. Central Standard Time. If this system were ejecting more favorably relative to the diurnal cycle, you'd already see a really intense low-level jet out here. But it doesn't really intensify until the upper-level dynamics eject by about midnight. Then you start getting the development of this low-level jet. You can see it's a little bit backed as well early on here across Texas, different than the day after, Monday, across Dixie Alley. Here you can see some of those dew points. Decent dew points for this system. So, but still, you can see the really deep dew points down here in the western and southwestern Gulf of Mexico. You can see the lower dew points up here right near the coastline, near the southeastern Texas coastline and southwestern Louisiana coastline are definitely moderated because of those below normal temperatures. And just the northern Gulf of Mexico this time of year is relatively cool out there. I think that this was a deal breaker for that convective line we were chasing in the Lake Charles area, which was a good thing, kind of the saving grace for that system, having that belt of stable air right along the coastline, not allowing that convection to really mature before it hit that strongly sheared environment over southwestern Louisiana. But possibly a little bit further south, you could also see the development of severe weather. Let's now see what the surface-based CAPE is showing here. It does have some decent CAPE across the Texas Hill Country, south of Abilene, south of the I-20 corridor. Some of that surface-based instability by midnight begins to lift toward the DFW area. So even despite the greater dew points being in the western and southwestern Gulf of Mexico, you're still realizing dew points in the 60s by about midnight Sunday night here, especially southwest of Dallas-Fort Worth, down near the Brownwood area. But look at that capping inversion. Still so far ahead of that upper-level storm system. Just not getting an erosion of that cap yet, despite relatively favorable photographs down there for tornadoes with that low-level jet accelerating above 40 knots there. Critical angle, relatively shallow at about 45 degrees. But really the thermodynamics are what is not favorable for tornadoes there by about midnight. See how that CAPE evolves after midnight. You can see the expansion of that instability axis up to the Red River, up to the slight risk area by about 2 to 3 a.m. Central Standard Time. Likely as that trough begins to eject, the low-level jet's going to increase. You're going to get warm convection out here, elevated convection. That definitely could reach severe limits. You can see a 50 to 60 knot low-level jet here, but I just think that the majority of that instability is not going to be surface-based. But you do have an erosion of that cap across North Texas late. This is the strong cap off to the east across East Texas near the core of that low-level jet. This is an erosion of that cap as that trough is beginning to eject in the middle of the night on Sunday. Let's look at a forecast sounding in the middle of that. And you can definitely see that the cap gets eroded finally when that upper level support ejects, despite marginal dew points in the low 60s. Still relatively decoupled. You can kind of see this development of a nocturnal inversion. See how that temperature line noses down a little bit right near the surface. That's why you have such a strong low-level jet just above the surface. You have a decoupled boundary layer here that causes a weakening of the surface winds, an acceleration of the low-level jet just above the ground. In this case, above 60 knots. So if you can get enough warm advection here, eventually a couple of storms have a chance of becoming surface-based and drilling through that shallow, stable layer. But really, the threat of tornadoes is incredibly minimal with this setup due to the low-level thermodynamics, the late arrival of that upper-level system, kind of some shallow critical angles here. A negative contribution to the storm relative helicity between 1 and 2 kilometers with this loop. But there is still some non-zero storm relative helicity in the lowest 2 kilometers within this hodograph here, enclosed by that hodograph curve. Of course, we got to look at the HRRR and see what it does. But here's what the NAM is showing. It's hinting at this elevated convection developing near the Red River into southeastern Oklahoma, maybe on the southern fringe of this, down to near DFW. Late night tomorrow night, maybe early tomorrow morning, you could get the development of some severe weather, low-end severe weather. I'm kind of surprised that there is a slight risk being issued for this area with a weakening upper-level storm system. Usually these weakening upper-level systems that are shearing out like this have a tendency to underperform. One positive, though, with a system that's shearing out like this is you can get some more veered upper-level flow. But the problem with this veering out or shearing out upper-level system is you usually also get a veered and relatively weak low-level jet. But in this case, with this thing coming in the middle of the night, you still get a pretty stout, strong low-level jet. It still is relatively veered. But again, the core of this low-level jet is over an area that is lacking in surface-based instability. We could show this with the surface-based SIN, convective inhibition. So this is by 12Z by tomorrow morning. There is a nice slug of surface-based instability here, centered over DFW into southeastern Oklahoma, right over that slight risk area. But the core of the low-level jet is further east, where there's a lot of low-level convective inhibition. And out here where the capping inversion does erode, you still do have some remnant low-level flow here. But really, look at the veering of these low-level winds on the backside of that low-level jet in concert with that area that does have a little bit of surface-based instability. But you look closer to the soundings, and you can definitely see the downturn of the temperature, a little shallow, stable layer right near the surface there. And really, the only instability is elevated above that shallow, stable layer with this sounding, and that's why you get basically marginal severe weather with this. And look at how the photographs change on the backside of that low-level jet as that system continues to shear out through Monday morning as it lifts off to the northeast. You basically get a bigger contribution to the negative storm relative helicity between 1 and 2 kilometers than you do between 0 and 1 kilometer in the photograph lower in the atmosphere. Let's see what the HRRR has, the morning HRRR for developing convection. It also kind of has the development of this surface-based instability here across northeastern Texas, and it even has the convective inhibition a little bit further east than the NAM is showing. So I bet that the HRRR is a little bit more favorable for the evolution of convection here. It does have kind of a skinny squall line. So here's what we have. Late night tonight at around midnight, we do get the development of some severe weather on the north side of that instability axis down in the Texas Hill Country to the southwest of DFW. This is at about 11 p.m. Central Standard Time. So if you're a storm chaser and you want to try to chase this nocturnal event, get down near Brownwood by about 10 or 11 p.m. and you'll likely see some lightning, maybe even some transient elevated supercell structures down here on the very north side of that instability axis. We can see what the HRRR has for dew points. It does have some low to mid 60s dew points up here. Again, the greater dew points are way down south in the Gulf of Mexico, the western and southwestern Gulf. That's finally going to open up probably toward late March, and that's when I think you're really going to see the advent and the development of the core of this severe weather season. You could definitely see the moderated dew points over the marshlands and shallow Gulf waters there on the north side of the Gulf of Mexico. This is really going to kill the severe weather events. Last year, we had an El Nino in the Pacific, and you had above normal water temperatures over the Gulf, so you had a lot of mature supercells making landfall in the central Gulf Coast. In this case, if you get a similar setup, you just don't get the development of mature convection over the Gulf of Mexico, at least in the near waters to the coastline. Maybe further south in the open Gulf of Mexico you could, but you definitely have below normal sea surface temperatures out here in the Gulf. That's going to lead to a delayed start. Earlier in the evening on Sunday evening, though, you might be able to tap into some of these deeper dew points located over the western Gulf, which is not as cold as the rest of the Gulf of Mexico. That could cause some deeper dew points to arrive to the Texas Hill Country to the southwest of DFW. Maybe the development of some elevated supercell storms down there. Looking at the supercell composite to the southwest of DFW, that's where it's maximized over that Texas Hill Country. Some double-digit supercell composite numbers. But still, quite a bit of a capping inversion down there. So we're probably going to be talking about elevated supercells down into the Texas Hill Country initially, even though those photographs are quite favorable early on. This is the best photograph co-located with instability that can be found from this entire event. And this is late Sunday evening toward midnight down in the Texas Hill Country to the southwest of DFW when those favorable photographs develop. Looking at the instability down there, most of the instability is back further west to the northeast of Del Rio. You get a little bit of funneling of those deeper dew points up the Rio Grande Valley there. And but Cape's right around 1,000 surface-based Cape, but still there is just a bit of surface-based convective inhibition dominating the southern Texas Hill Country, except for this little stripe here near Brownwood area to the south of I-20, southwest of DFW. Within this area, maybe those supercell storms might have a chance to drill down into that shallow stable layer. And these photographs, despite the low-level winds already beginning to veer out with that shearing upper-level system, are relatively shallow. So I think you could get some transient supercell structures here. The problem is they're going to be elevated. They're going to be less likely to tap into that low-level wind shear when they're elevated above that convective inhibition. And that's going to make those low-level mesocyclones less likely to form even with those elevated supercells. And that's going to prevent them from being able to drill down through that shallow stable layer. But this is the evolution of that surface-based instability here. This is at 8Z, so about 2 in the morning. This upper-level energy begins to arrive across the DFW area. You can see an expansion of that area of surface-based minimal convective inhibition. Here it's starting to move over the DFW area just after midnight. And along with that, the severe weather potential begins to increase across DFW. So between about midnight and the early morning hours, you can see this convective system of elevated storms, some embedded elevated supercell structures, maybe enhancing the severe weather a little bit. And it does try to backbuild down into the DFW area where there is a little bit of surface-based instability down here. So if you can get a sustained low-level mesocyclone that's able to build down toward the DFW area, there is a chance, non-zero chance, very small but non-zero, that there could even be a tornado despite these relatively sheared, veered out photographs here with relatively minimal storm relative helicity as well. Surface wind, a weak with that low-level stable layer there. Definitely some decoupling between the surface and 1 or 2 kilometers above it, where you have that low-level jet accelerating above 40 knots, but it's already veering big time by the time that convective line arrives near the DFW area. You can see these are almost due southwesterly winds at about 40 knots between 1 and 2 kilometers. But that convective line does eventually move into DFW with that marginal severe weather threat. These elevated storms are moving a little bit more quickly from the Red River into southeastern Oklahoma by 10Z or about 4 in the morning, Central Standard Time. Starting to move into areas like Poteau, Broken Bow, probably see some lightning, hear some thunder early in the morning. And then a couple of these storms down near the DFW area, as you're getting closer to the morning hours, may have a chance of becoming surface-based, but by this time, the low-level jet is already starting to move off to the east. Well, you still got a chance. It's starting to veer back here along DFW, so there is a very narrow window between about 7Z and 10Z, between about midnight and 3 in the morning, where maybe you can get a surface-based storm down here in the DFW area before that low-level jet begins to eject to the northeast. So the wind fields don't look too bad, but I think that the problem is that this system is ejecting across the southern plains in the middle of the night, and it's pretty decoupled at the low levels thermodynamically, and that definitely facilitates the development of a strong, relatively veered low-level jet in the warm sector here. If this system were ejecting in April, we might be talking about a pretty decent chase day here across North Texas, maybe even Dixie Alley, despite that system really veering out with time. But really, this trough peaks in the southern Rockies and then ejects from the southern plains as it's weakening and shearing out, and that's really the issue with this severe weather event. And then the kicker system coming into California here on the backside. But we've seen this happen a lot during this winter, where these systems will peak in intensity over the southern Rockies and then shear out over top this anticyclone over the Gulf of Mexico. We should probably look at some sea surface temperature anomaly plots for the Gulf of Mexico next, just to confirm. Could always go back to Supercell Diagram. I'm thinking about getting this as a tattoo, a giant tattoo on my back of this Supercell Diagram here. Another thing with those photographs being a little bit closer to straight line photographs instead of those big loops is you get kind of a equal dominance of the left split supercells. There you can see that left split lifting off to the north from the dominant right mover that produced the Tuscaloosa EF4. You usually get an equal dominance of the left and right mover instead of just an absolute dominance of the right mover into a tornadic supercell. You'll probably see that as well tomorrow. Even though the storms will be elevated, you'll still probably see some splitting supercells within that convective system there in North Texas into southeastern Oklahoma. But it just doesn't look like a big tornado threat. And that's also why the Storm Prediction Center has less than 2% tornado probabilities for this area. Maybe on the southwestern side of this, there could be some surface-based storms. And I would probably extend this slight risk down into the Texas Hill Country there to the southwest of DFW. I even think the chance of the most substantial severe weather with this event is going to be southwest of DFW down into the Texas Hill Country, probably about 11 p.m., maybe toward midnight. That'll probably peak down there. Maybe some embedded supercell structures. The hotographs, even though for elevated supercells, still look a little bit more favorable up there. And then probably an evolution of an MCS to the north of DFW into southeastern Oklahoma. Maybe the development of an isolated surface-based storm between about midnight and 3 a.m. down in the DFW Metroplex. But the shear will be ejecting, and you've got a lot of an abundance of very shallow, stable air right near the surface with this setup. And there's a lacking of a risk at all for Dixie Alley on Monday, as that system almost loses its identity and basically just becomes a jet streak lifting up and over top that anticyclone over the Gulf of Mexico. So I'm going to continue to watch this really closely. I'm very excited for the class on Varsity Tutors on Monday night. After that, I'm going to begin weekly educational content, Storm Chase EDU content sent through my Facebook supporter platform. You can check the link to become a Team Dominator supporter in the bio of this live stream. And we're going to be providing that educational content every week, even through the storm chasing season. Some of the times I might be in the field kind of talking about a severe weather setup or showing what we're doing science-wise. But I do really enjoy teaching severe weather forecasting, chasing tornadoes, supercell structure. I definitely enjoy all of that. In fact, educating on all aspects of meteorology. So this is definitely going to be a new direction that we're going to proceed with, in addition to, of course, nonstop storm chasing and research. And but I hope you guys enjoy my weather reports. I'm going to keep them coming. And tomorrow evening, if the severe weather does ramp up or if anything changes, I'll be back live again to update it and break down that radar data as the severe weather's happening. But thank you, everybody, for joining me this Saturday morning. Never stop chasing.